plan for today is we are going to get into quadratic equations. Now, one of the things that the GMAT loves to test with quadratic equations is definitely the identities. They love to test difference of squares, and they love to use it in different circumstances on the test. So for sure, these can be mixed around with other topics, but yeah, in general, I think that they like to, use these things, very specifically with number properties. They can do quadratic stuff on their own. They can definitely, of course, use exponents. So yeah, there's a lot going on with that stuff. So we're going to jump into that right now, do about 30 minutes, and we'll do some Q&A. Keep in mind, I don't see as much of it being done in DI, solely because, data sufficiency now is not pure math, right? And then, beyond that, you don't see it as much in, say, the graphing, table questions, stuff like that. All right, so let's take a stab at this first question here. As always, put your answer in the chat box, and then we'll kind of talk about the result. So everybody start with this question right here. Give you guys about 2 minutes, then we'll talk. So let's see what you guys have got going on here. I see a lot of correct answers. Now, did you guys recognize right off the bat that we're pretty much dealing with prime factorization here. That's a big way that we're going to have to deal with this, plus difference of squares, of course. Because to me, both of those are, important components of this type of question, difference of squares and prime factorization. So when we're talking about this question here, one of the important things we have to do is recognize that we don't necessarily have to do this math out, right? Now you can do some factoring out and stuff like that, but in general, doing difference of squares is nice because it's a nice clean way to deal with this question, right? So 5 factorial plus 4 factorial, 5 factorial minus 4 factorial. If you have those memorized, which you should, that's 120 plus 24, 120 minus 24. And the reason to know to prime factorize is you see it's equal to these prime factors over here, which is definitely helpful. So then you have 3 to the B, 13 to the C, so you have 144 times 96. Oops, hold on, this pen tool's pretty annoying sometimes. Times 96, and then, equals 2 to the A times 3 to the B and times 13 to the C. Now, you should recognize pretty quickly that you're not going to have, a 13 to the C. There's going to be no 13s here. You can tell pretty quickly that 144 and 96 aren't going to have a multiple 13. But even if you didn't, you'll get there through prime factorization. So you have 12 and 12, 4 and 3, 4 and 3. That ends up giving you 2 to the 4 times 3 to the 2, right? And then 96, if you break that down, 2 and 48, 8 and 6, so that's 2 to the 3, 3 to the 1, 2 to the 1. So you've got 1, 4, 5 2s here, so another 2 to the 5 and another 3 to the 1. And then, of course, you bring that over, that becomes 2 to the 9 times 3 to the 3. And then from there, add those together, you get a prime factor of 12. You can factor out a 4 factorial. You can do that. That's totally valid. I prefer difference of squares here, but what you did there is certainly a valid as well as far as factoring out is concerned. And factoring out is a big part of exponents, a really big part of exponents. So it's not like that's anything that's all that crazy. All right, so that's good here. Another one that really uses difference of squares is this problem here. So take a look at this one next. Again, give you guys a couple minutes, and then we will discuss it here. Hold on. All right, take a look at this one here, then we'll chat for a couple more minutes about this one. So someone put an interesting thing in the chat here, with using unit digits here. Be careful. I think sometimes we use unit digits in situations where maybe, we shouldn't. This particular problem, I wouldn't necessarily say has much to do with unit digits, in my opinion. For sure, though, difference of squares is big when dealing with this type of question, for sure, which you'll see right now. So basically, the deal with this question here is you can tell that you have difference of squares, and difference of squares is always a helpful tool when it comes to making numbers smaller, like we talked about. If you had a calculator, we wouldn't really care about difference of squares here, but we don't. So you break this up, you say that this is 3 to the 4 minus 2 to the 3, 3 to the 4 plus 2 to the 3. If you're talking about cyclicity with unit digit patterns, I would say no. Again, the way that I deal with this is straight difference of squares. And it should be obvious because they're giving these to you in the form of difference of squares, and difference of squares can be used, very strategically as far as divisibility is concerned. So you have 3 to the 4 minus 8, right? So that gives you 81 minus 8. And you can start to see these answers. Like clearly you see there's a 73 there, and then there's a 73 in our parentheses, right? And then you've got, 3 to the 4 plus 8, that's your 89. And then it gets a little hairier here. You get a 63 and a 65. So, look, there's a couple of things that should be pretty obvious that don't work. Obviously, a 73 and an 89 because it's an accept question. And then, okay, 9 clearly goes into 63. So we have that going on, right? And then what about, okay, 11 and 15? Well, the thing is, remember, 65 has a 5 in it, and 63 has a 3 in it. So there's your 15. So it's divisible by all the following but the 11 there. And that's how we kind of finish this guy up. So 11 is our answer. We'll do one more. But yeah, so I would say definitely do difference of squares here. It's clean. It's simple. In fact, I'll show you guys a unit digit pattern option for something like this, so you can see what I'm talking about. But it's there's a time and a place for unit digit patterns. Let me put it to you that way. So if difference of squares is the play, try to use difference of squares, I would say. All right, so take a look at this guy here. So yes, this is okay. So I'm glad a lot of you guys noticed this. So this is where difference of squares can be very, very useful. And it becomes obvious because you're seeing these very large numbers. So this whole idea of you know, basically being in a situation where you are thinking you need a calculator for this stuff. You don't, right? Because there's no calculator on this section. So what you're going to eventually have to do is deal with difference of squares, or excuse me, unit digit patterns, but then this is unit digit patterns plus difference of squares. So you're not doing difference of squares right off the bat. You're first doing your unit digit patterns, or excuse me, you're not doing unit digit patterns right off the bat. First, you're doing your difference of squares. So here you have 2 to the 15, or excuse me, 3 to the 15 plus 2 to the 15, 3 to the 15 minus 2 to the 15, and then on the bottom, you'll notice that these cancel out. Like again, this is very strategic. Cancel, cancel. So now you say, well, what do we do with this here? Well, we're not going to use a calculator because again, we don't have a calculator, right? But we can use our unit digit patterns very quickly. 3 to the 1 is a 3, 3 to the 2 gives you a 9, 3 to the 3 gives you a 7, 3 to the 4 is a 1. Do you have to have these memorized? Not necessarily, but you could. I prefer just to write them out this quickly. And then from here, you say, okay, well, where does 15, because it's a repeating pattern of 4, 3 to the 16 is going to give you a 1, go back 1, 3 to the 15 is going to give you that 7, and then you do the same thing with 2s. 2 to the 1 is a 2, 2 to the 2 is a 4, 2 to the 3 is an 8, 2 to the 4 gives you a 6, right? Same deal, 2 to the 15, so you do 2 to the 16 because it's a repeating pattern of 4. That's going to give you your 6. 2 to the 15 is going to give you your 8. So when we add 8 and 7 together, what do we get? 7 plus 8 equals 15. So your unit digit has to be 5. Another tell here is the fact that, you know, we have different very large values, right? Like very, very large values, but different unit digits. That's how you can tell the answer's A. All right, let's do one more kind of in a similar vein here, and then we can do some Q&A, and then we can kind of go from there. So the last one I want to do is this one here. All right, so take a look at this one here. Give you a couple minutes. Hopefully you guys are seeing that this is pretty straight difference of squares here, because it is, of course. No unit digit patterns here, none of that. So what we're dealing with in this question, again, is just breaking it up solely with difference of squares. So 3 to the 5 plus 2 to the 5, 3 to the 5 minus 2 to the 5, right? Now, again, exponent's probably worth memorizing. 3 to the 5 is 243. It's worth getting that memorized. So we have 243 plus 32, 243 minus 32. 243 minus 32 is going to give you 211, and then plus 32 is going to give you 275. Right away, the 211 goes out. It's clear that the 5 and the 25 are out, because those go into 275. Now, the 55 and 75 are interesting. Remember, 75 is a multiple of 3, and you're never going to have a multiple of 3 in 211 or 275. So because of that, and you can just figure that out by, adding the digits together, basically, and seeing that you don't get any multiples of 3. Therefore, 75 is not going to go in. Now, worst case scenario, could you, add these, could you actually do the math out? I mean, you could. You just don't necessarily need to. So just keep that in mind. All right, so that's it. I think this was a good set of questions. Now we can jump into, some Q&A. Does anyone have any, questions in general about their prep, about using target test prep, anything like that I can answer for you? The answer to the first question was 12, because we added together the primes, the number of 2s, and the number of 3s, and we ended up getting 12. Remember, there was 0 3s. Yeah, these are linear and quadratic. So yes, that's exactly where you would see them. Linear and quadratics, correct. If you buy the 6-month option for on-demand and you need more time, like, we can help you out with a discount to do the extension. So yeah, I mean, we're always happy to try to help and make things work. 55 is not a multiple. 11 and 5, 11 goes into one of these values and so does 5. But the point is what I was trying to make is you don't have to actually go there to figure it out. Like, the best thing to do is to figure out that 75 doesn't divide in. I think that's a much cleaner way to deal with this, basically. All right. Any other questions here? How to use TTP? Well, we actually have an additional study plan, like a post-TTP study plan that I could send you. That includes the official guide. It includes a lot of custom tests. So to me, that would be a great way to use target test prep. We do some verbal webinars, so I imagine at some point there might be a webinar on reading comp, yes. That's very possible. Yeah, as I've said, I don't think I've told you this in the past, you don't need to solve GMAT Club questions. So, if that's something you're doing, obviously you're doing it, but it's not something I think you have to do. I think I would stick to our stuff and official questions. Any other questions? As far as like review goes, yeah, I mean, I think review, you can certainly, look at notes, look at flashcards. There's all sorts of stuff you can do to, make sure you're doing, the appropriate review and stuff like that. I'd say flashcards and notes are the big things to be doing, though, for sure. Let's see. Any other questions? Yes, they're Tuesdays, office hours for on-demand. How do you gauge the level of difficulty? I mean, I guess it's tough. There's no, like, you just have to kind of use your judgment about what those difficulty levels are. Not that you need to really know them. Yes, I would say, well, you can take a practice test right off the bat just to get a baseline score. And then after that, I would say wait to take any practice tests till you're totally done with Target Test Prep. I can't tell you how to use GMAT Club, but if you're looking for more critical reasoning stuff, you could certainly just get the official guide. That's one thing you could definitely do. The unit digit lesson is in number properties. You can check it out there. It's in number properties. The next webinar is probably going to be next week at the same time. All right, cool. If there's no more questions, then I guess that's it. Why don't we use Zoom? I just prefer WebEx. All right, cool. So thanks for coming, everybody. Good work today. We will get back after it hopefully next week. Keep me updated. If you need anything, you know how to reach me. Just reach out to us on live chat, and we'll be around. Thanks again, everybody. Talk to you soon.